In part 1, the Southern Ocean revealed itself as a force that shapes the entire planet. Its currents move more water than every river on Earth combined. Its winds have been building for millions of years, and if it stopped, the climate would collapse within decades. But that was only the surface. This is part 2, and this time we go down. Because beneath the ice there is a world science has barely begun to reach. Most of it never touched by human hands. Most of it never seen by human eyes. Like Lake Vostok. If Antarctica had no ice, it would just be a lake. One of the deepest in the world, visible, mappable, reachable, known for centuries. But Antarctica has ice, and Lake Vostok lies 4 kilometers beneath it. Liquid, dark, and sealed from the outside world for at least 15 million years. The reason lies in 2 opposing forces. The ice above exerts enormous pressure, enough to lower the freezing point of water far below what the surface world knows. At the same time, heat rises slowly from Earth's interior through the rock beneath, warming the base of the ice from below. Caught between these 2 forces, the water neither freezes nor escapes. It simply remains, perfectly sealed. A Tupperware container at the bottom of the world. Lake Vostok stretches across an area comparable to Lake Baikal in Russia, one of the deepest lakes in the world. At its deepest point, it descends 800 meters. Without the ice pressing down on it, it would rank among the greatest lakes on the planet. And still, most people have never heard of it. For decades, the question of whether to drill into it was contested. Any contamination from the surface, a single organism carried down through the borehole, would compromise 15 million years of isolation in an instant. When Russian researchers finally reached the water in 2012, they used kerosene to seal the drill shaft against the outside world. The samples that came back were immediately disputed, but the finding was not. Life, bacteria, some bearing no resemblance to any known species on Earth. Organisms that had spent millions of years adapting to permanent darkness, extreme pressure, and complete isolation from every other living thing on the planet. Lake Vostok is not an exception. Scientists have now identified more than 400 subglacial lakes beneath Antarctica, connected by slow rivers moving silently under the ice, fed by a heat source that has been present long before any of this ice existed. The same heat that keeps these lakes liquid has been shaping this continent from below for millions of years. That heat has a source. Beneath the western Antarctic ice sheet lie at least 138 volcanoes, the largest volcanic region on Earth, and one of the least known. Most are dormant, but around 2,000 years ago, one was not. A volcano in the Hudson Mountains of West Antarctica erupted beneath the ice, violently enough to scatter ash across thousands of kilometers. No civilization recorded it. No one was there to witness it. It was discovered centuries later, preserved as a thin layer of ash inside an ice core, frozen into the record of a planet that keeps its own history. These volcanoes bear little resemblance to the ones most people picture. No cones rising from the ground, no visible craters, no rivers of lava. They function more like heat plates, spreading warmth across a wide area from below, slowly and silently. The ice above melts not in dramatic bursts, but gradually, the water finding its way downward through the landscape, pooling in the ancient valleys and basins beneath. This is what sustains the lakes. The volcanoes and the subglacial water are not separate phenomena. They are one continuous system. Heat generating water. Water carrying the conditions for life. The crust beneath West Antarctica is thinner than almost anywhere else on Earth, a consequence of the ancient breakup of the supercontinent Gondwana, which stretched and fractured this region over millions of years. Magma sits closer to the surface here than beneath most of the planet. Should a major eruption occur beneath the western ice sheet today, no system exists capable of detecting it in time. The seismic network across Antarctica is sparse. The warning, if it came at all, might arrive years after the process had already begun. What that would mean for the stability of the ice above and for sea levels across the world remains one of the more unsettling open questions in Earth science. The fire has been burning quietly for a very long time. Let's descend further. On the floor of the Southern Ocean, at depths where no sunlight has ever penetrated and the pressure far exceeds anything the surface world knows, the seafloor fractures and superheated water erupts from below. These are hydrothermal vents. Seawater seeps through cracks in the ocean floor, is heated by the rock beneath to temperatures approaching 400 degrees Celsius, and is expelled back into the surrounding sea. At this depth, the pressure is sufficient to keep water liquid far beyond its normal boiling point. What emerges is not steam, but a scalding, mineral-laden column, black with dissolved iron, zinc, copper and sulfur drawn from the Earth's crust. Black smokers. The minerals crystallize on contact with the cold surrounding water, forming dense, billowing clouds. Over centuries and millennia, those minerals accumulate into structures, chimneys rising from the seafloor, some reaching 60 meters in height. Towers built entirely by chemistry, in absolute darkness, at the bottom of the world, and around them, life, not in spite of the condition, because of them. Tube worms reaching 2 meters in length, blind shrimp, dense colonies of mussels and crabs adapted to temperatures that would be lethal to any surface organism. And at the base of it all, bacteria deriving their energy not from sunlight, but from the chemical oxidation of sulfur, a process called chemosynthesis, and an entirely different foundation for life than anything previously known. When hydrothermal vents were first discovered in 1977, they altered the way biology understood itself. The assumption until that point had been absolute. All life on Earth depended, ultimately, on the sun. The vents proved that wrong. In the year 2000, a research vessel moving through the Atlantic accidentally detected a field of white chimneys on the seafloor, structures unlike anything previously recorded, sustained not by volcanic heat, but by a chemical reaction between seawater and rock alone. No magma, no volcano, just the slow exchange of minerals in darkness, generating enough energy to support an entire ecosystem. They named it Lost City. Formations consistent with Lost City exist on the floor of the Southern Ocean. Most remain unmapped. Some have never been observed at all. The seafloor here is neither empty nor silent. It is among the least explored environments on the planet, and what little has been seen continues to revise what science considers possible. In Part 3, meet the residents. What lives in the Southern Ocean is stranger than what lies beneath it.